currently like information security here at UNSW. Yeah, cool. And so rest is regular computer science. Anyone else? Other degrees?
I think there's a couple of first years.
First years? Excellent. Who are the first years? Excellent. Hello in the back. It's all good. All good. Thanks for coming. So I'll just get started. So my name is Ruben. You can find me on Slack or Twitter as Boxy. And this is Matt. So we work at PWC. I was told it's okay to record this. I'm just not allowed to swear. So just.
Oh no, even if you swear, we'll just bleep it out. So go nuts.
Excellent. Thanks.
And like, if you start showing stuff you shouldn't show, we'll just black that out later.
Cysca solutions.
Or like, even if you start attacking UNSW or live bug dummies, we've had to bleep out 3/4 of the northern spectrum. So, every show. Go nuts.
Cool. So a bit more serious, I think. So we're primarily pen testers. I focus on pen testing and security architecture. So I work largely with big financials onto like how to secure transactions, customer data, stuff like that. But in my spare time, I enjoy mostly just exploit writing, binary exploits, and web is probably where my area of expertise is. I'll let you do your story. I don't know.
All right, we'll find out. Hi, I'm Matt. I should stand up. Like Ruben, also mostly doing pen testing. I work more in kind of like the health industry. That's kind of where I've been working on for the last year and a bit now. Started as a developer, so I've made a lot of mistakes, and that's how I learn, and that's how I know how to break things. Cool.
So who here played Cysca? Like 2017? Cool. That's good. You guys did really well. I'm legit impressed. So for a bit of context, so for those that played Cysca is a bunch of categories. Like there's anything from just a corporate network pen test to just random challenges to web application challenges. I led the web application pen test stream, which was roughly, I think, 7 or 9 challenges, depending if you count the warm-up challenges. And the goal here was to just basically produce more challenges than you have time. And literally the only person in the country that was able to prove us wrong that we had not enough challenges was you. Like, I'm very impressed.
4 hours of challenges. Like, it will take a 3-hour break.
Yeah, well done, well done. Like, no, so, like, UNSW was almost the only team to solve all challenges, so well done. So, for a bit more context, like, this competition is actually quite massive. So this was just the web component. Well, in total, there were 90 challenges. We had 8 web challenges. We had 176 solutions submitted. So that's out of the 300 plus students. So what that means is that, like, we write challenges for the top teams in the country. Otherwise, it wouldn't be a fair competition. But that also means that there's probably quite a large gap. So I think this is one of the reasons why we're here, is to also get everybody who still needs to learn this. Like, UNSW is very well established, but we do this at other universities as well, to make sure that this is clearly a skill that's developed by students, because this is the skill that we as professionals look for when we look for candidates. So we had like 30% increase of competitors from 2015, which like is awesome. And 160 web servers. So each team gets its own environment. So in total, we had over 1,200 VMs just running challenges. So that excludes all like VPN infrastructure, website, stuff like that. So it's quite a massive undertaking. We do that together with quite a bunch of other people and just not enough sleep. The amount of time I woke up at like 4 a.m. to make sure that you all had like a fun 24 hours. There were many. The 250 players online at 2 a.m. was epic because we were also still awake, and like the IRC channel just turned into this massive like Planet of Trolls, which was funny. So like at some point people started asking like, is this like the right place where I need to look? And like all the admins just go, maybe. And, like that was it. Like not very helpful. We are not helpful at 2 a.m. So if you have any questions, just ask them like just after 12. After that, just. Anyway, we'll move on. So yeah, you did really well. UNSW 1 and UNSW 4 ended up on like being the first teams to solve. And then, but I'm very glad we have a lot of people who haven't played. So what I've done is I basically set up the environment again, so we can play them today. So this is quite useful for the people that think in like boxes and lines like I do. I love architecture. Basically what we did is we developed 2 separate VMs. One was basically a simple dashboard that would show, so the theme was IoT, because it's a fun theme because everything is broken in IoT, so we developed 8 broken IoT devices. So we had one VM running a bunch of broken virtualized IoT devices, which was just basically what we built it with was Flask, I think Flask or Hugo, like Python web frameworks, and we ran those behind Nginx. So they run on port 8000 to 8008. And then we had a dashboard, which was basically just a pretty UI that's connecting to the backend. Most of the time, the web calls would be made from that server. So your browser wouldn't be making the calls directly to the IoT device. You can, but that's not how the interface would work. I'll show you a little bit more in a bit. Most of the challenges are designed around real-life vulnerabilities that we found. Like most of them have been modified to just be fun to play, and of course they needed a hilarious name. So, but most of them have been built on, and I'll tell you a bit more. But time to get swifty. And in tradition in Cysca, there is always 1 or 2 warm-up challenges. Basically, all that they do is to just make sure that you're awake and your browser is working. So feel free to grab your laptop and just go to that IP address. And that should. So you can solve both of these by just doing view source. Sorry? Yeah, man. They're good. I forgot to do one flag. So like build flag, this is actually what we use in the environment to, like these get replaced in each environment with team unique flags. Did you see how I got the first flag, by the way? So just view source and scroll to the bottom of the page of your login. So then your next step is to activate your very expensive dashboard. So I've highlighted the line that you're looking for on the screen. And so you need to make that line validate. There you go. Done?
Expensive software, I'd say it's well protected.
Yeah, it is. Yeah, it took us a lot of time. Yeah. It's okay, we actually risk accepted this issue. So, work.
Yeah, I remember this. I remember how we got to take the last one. So it was the stupidest challenge.
So I assume everybody knows about the developer tools in Chrome. If not, like, learn them. They're genius. They're great for CTFs, but also for any type of development you're doing. The good thing is, like, the console will just allow you to pretty much execute anything. In this case, because we need to validate the line, we'll just grab the line, just execute it. So it will give us the value that we need to activate the dashboard. And I think somebody already activated it. We're all working in the same environment. So, but that's the value. Just punch in and click activate. Does that make sense? Yes?
Yes.
Cool. If it doesn't, just yell out, because I'll explain it again. Yeah, man. So originally you would land on this page and there would be an input field saying to how like you need to activate this dashboard. Otherwise, if you go to any of the others, it will just log you out. Okay. So you won't be able to play any of the other challenges. And in the competition, none of the other challenges would actually unlock until you solve this one. So what you would do is you would view source. And at the bottom, basically, this is your activation code. So this line, that if statement, will have to validate. So you can kind of solve this in two ways. So the first one is you can just find out what the actual value is that needs to validate against code, which is your input value. Or you can just execute that post request, which will call an endpoint. So this is a classic example of client-side validation of something that shouldn't be validated client-side. Does that make sense? So you would have, like this code, you have to move server-side. Like, we'll validate your license key server-side, not in JavaScript. So for those that are now, I think the next one we'll have a look at is the IP webcam. And I'll just tell you a little bit more about like how you can get started about solving this, because I think this one, I thought this one would have been solved a lot more, but I think the challenge here is there's already a lot of network traffic in the background. So let me just show you. So in this case, we have an IP, I think it's IP webcam, I hope. So what we've done is all of these devices are constantly asking for like, hey, what's my latest status? So what's my name? All these fields get refreshed pretty much every 5 seconds. So there's quite a bit of network traffic. The thing is, there's one that stands out, which is your status call. And I think this is the one you want to have a look at. So it's an SQL injection challenge. And the status call is the one that you were supposed to find. And it's, in this case, it's the, bear with me. Yeah, it is in status, sorry. So it's the X browser header that you want to look at. So I'll tell you why. So in the actual RFC for HTTP, anything starting with an X minus is, or just an X, I think, is a custom header. So you can use this. And in this case, that's a clear indicator. This is something that's developed by, in this case, TikTok. So I'll talk a little bit to a tool you're going to need. So there are a few you can use. In the sector, we use Burp. Other two options is you can either use regular Python. So Python requests is your library, like that will make you very happy. Or the other one is Zap. Zap Proxy are two of the tools that you can use. So what I've done in this case is I'm just putting who here knows Burp or Zap or any web app proxy?
Burp in our web apps here. So.
Oh, cool. Excellent. Cool. Okay, I'm not going to dive into it too much then. In this case, you want to get that status request that goes out specifically to the actual device, to the IP cam. And I can't make this bigger, I think. Cool. So I'll just show you a bit more about like how I actually got here, right? So the one IP address you typed in at the start is this one, which is your dashboard. And any traffic going to that, of course, that's of interest. But when you look at, there's a second IP showing up that is getting requests. In this case, that's strange, because all the other, so if you actually look at your HTTP history, it will tell you a lot more. Everything here is going to our dashboard. Like all of these, that's all our dashboard IP, just except for these, which is strange. So that's in this case the one that we grab. So we send it to repeater. So click repeater. Repeater just allows me to just make changes to anything in the request and see the response quite quickly. This is just very easy when you have such an interactive app like this, or when you're testing APIs. So because it's an SQL injection, X-Browser is the one that is odd. We can either just actively scan this, but generally CTF challenges will either make scanning impossible or just like not very useful. So we're just going to go and change them manually, right? So the minute we change that to a single quote, we get like, okay, something is wrong with your SQL statement. I'm going to leave it there for a while and see how you go. How are people going? So I think one of the challenges here was that the data you're after is actually not in the same table as where this statement is being executed. I think that's the main challenge. So there's, like, often with SQL injection, you don't actually want the data out of the table that the query that you're executing is querying from or is inserting in. You actually want to query other tables. So if you're executing a select and you want to include details from other tables, any idea of how you would do that? Yeah, you would union your results. So who actually, during the competition, read the actual documentation that came with the devices? Yeah, so the documentation initially appears like just not very useful, but there's actually stuff in there that you can use. So in this case, it's clearly making a reference to like a login, like username, admin, password. Like there's some status API calls. So the status API call is return status from the camera, and then it has all the other endpoints as well. So I think in this case the reference to the username and password is quite key. So which table would often be used if you're storing user credentials? Like you have a users table. So you can either like approach it this standard SQL injection approach, but SQL map in this case will just provide you with horrible results because we made every single call return a 200. So SQL map doesn't actually know what's going on. Now you can do tricky stuff with where I think SQL map allows you to say like if you see this string on the page, then I know that I'm still in an error condition. I don't think I've ever seen this work properly, but I think the initial goal was to just break SQL map. And you can do that by either returning always 200s or by just starting returning like random HTTP response codes. So in the interest of time, because I am planning on running through every challenge. So in this case, the answer is just provide like a regular valid value or just nothing, just single quote, and then union everything with the username and password, which are very common columns in your users table, and that will return you like a very strange like data structure that is not like the admin panel will break, but it will give you your I think your flag. Oh, your credentials.
Oh, keep the hash.
Yeah, you need to crack the hash. That's right.
Always a hash.
Yeah. So I think.
Did you see that into Crack Station?
Say that again.
Did you see that into Crack Station? Because I remember I found it on Crack Station.
So we actually chose a password that was already online.
Oh, okay.
Yeah. Cool. It's up here.
Obviously, my
Yeah. Oh, that's Monash. But yeah, it's just an MD5 hash of password 2016. So tools you can use. I use, I think, Find My Hash on Kali, which is just like, don't ever use this if you're on a legit pen test because it will query online. So it will query every online hashing store. So don't do that with client data. But for CTFs, it's excellent. I think it just says like 10 plus, like cracking station, or just query like, do you have this hash? If so, tell me what it is. So that provides us with a login. And then it's just admin. That should work, and it doesn't. That's oh, it's working for you? There we go. Cool. So this is this was quite funny because there's a password in the background which gets used later on in another challenge. So this was kind of really testing you because after a while you're just exhausted and you just don't notice it anymore. Yeah, that gets used for the. Yeah.
Yeah, but you can't actually read the handwriting.
You can.
There's like 3 letters in there that are completely indecipherable.
Yep.
So you just put like R and Jesus. Is this a C or is this an L?
Yep.
That doesn't make sense.
Let me actually show you. So writing a CTF is hard, right? I'll take it that a few people have written a CTF. Yeah? Like, one of the things that I aimed for pretty much, so we had roughly like 180 VMs running just web challenges. Let's say we find a bug an hour before we start, and we need to redeploy every single VM. Do I want to log into a machine, redeploy my code, then make all that last minute changes that you need in your scripts or move your files? Like, no. So what we did is pretty much for both VMs, we wrote single deployment scripts. Now that's not revolutionary, but for every single challenge, we wrote a solve script. So that means that every time we would deploy, we'd be able to run these. Linter is going nuts over these. And what it would do, it would run through every single step of the challenge to make sure that it's still working. So this allowed us to just pretty much in no time, which is what we had to do, like redeploy, make sure it's all still working, and then go live. So in this case, as I said, requests makes the request to the status API call with the SQL injection command that we want to execute. Then we collect the data that came back from that response. We validate if the value that we got actually matches an MD5 hash of the value that we expect. And then we call the actual flag. So running through these scripts, I got every single flag appear on my screen to make sure that you all could keep playing without us having to log into a machine and see if stuff was broken. I can highly recommend this for anybody writing. Like, it takes a bit of time, but it's like the most useful thing I had on the day. Cool. So it's just actually standard SQL injection. It's just hidden away a bit. This often happens during pen tests, where like SQL injection is not that straightforward anymore. It's sometimes just hidden in this really strange request that only happens because everything is a single page app these days, so it only gets executed like the call only gets executed when you reach a certain code segment in the JavaScript application that's running. So make sure you crawl your applications well. Keep your burp state, look for strange calls. Straight up SQL injection gets a little bit boring, especially for a lot of CTFs. Cool, I've showed you that. This is probably the favorite challenge name of all time. I'll tell you where this name came from. So it's Katy Perry, my data center. And it's a temperature gauge. And the challenge is built on a real concept, and that is, have you ever seen what happened to a chip that is in a room where the temperature fluctuates? So let's simplify that question. Do you know what happens if you put a chip in a very hot room compared to a very cold room? It slows down, yes. So what is the expected result if we do that with a chip that's generating random numbers? If it's either very slow or what's the worst case scenario? Yes, it becomes predictable. So that's what this was built on. So we're kind of looking for a way of changing the temperature in our data center. And now to the Katy Perry reference. Who here knows the song that I'm talking about? Yes, you know, you're hot and you're cold. So that's where the name came from. I'm very proud of that name, because it was very funny. Cool.
This is how the challenge writers get entertained.
Yep. So Katy Perry, my data center came from the encryption device challenge. Who's scanning my server? No one? No one's running the scanner. Cool. So obviously at the moment it's running at active cyber grades level. So it's producing most of the time random numbers. And the description in this case gave you everything you needed to decrypt this message. So the idea is just that every 5 seconds, I think, this page gets refreshed, and it provides you with the last 8 bits of the encryption key, the actual encrypted message, and the IV. How known is the concept of this type of encryption for you guys? Okay, should I so a block cipher, is that known? So block ciphers, I'm just gonna. So what block ciphers do is they have a block. They grab a block of data, and they grab some input, and an encryption key, and then something comes out of that. Then they grab this data, grab another block of data, and the encryption key, and encrypt that. This step you can't do the first time because you don't have the input. That's what your IV is. So that's block cipher encryption. Does that make sense? I'm always wrong. I'm always afraid that I tell this wrong, and that one of the students goes like, "This is actually not how block ciphers work." But so the IV in this case, let me show you. So I gave you the code to decrypt this message. The problem is you don't have the encryption key, right? So you need to find a way to affect the temperature of this chip. And I think that's the challenge. did you actually end up looking at the red herring that was in there? No? Like, I think this whole paragraph is just like nothing. I think that was the additional 4 hours that you need.
No, like before, I also just was wondering like whether I want to start because I don't do any of these. But I think I left this challenge to Glenn because I saw crypto and I didn't want to touch it. And then I finished all the others and realized this challenge changed completely after you finished the other one.
Yeah.
So like, after that point, this challenge is a lot easier.
Yeah. Yeah, because it looks like a crypto challenge and it actually isn't.
Yeah.
Yeah.
It's the stupidest challenge I can get across this. I can say that for every single one of these actually.
Yep. Yeah, that was very deliberate.
It's fun.
Good. So have a bit of a look around, and then in a bit, I'll just start talking to the solution. So the first thing you'll need is you'll need access to the temperature gauge. So that's where you want to start. So have a read through this, and then go from there. This is quite a hard one. I don't think if you're new to this challenge, this will take quite a bit of time to write up. But I was hoping to just have a quick chat about it to see if we can figure out how to approach this rather than actually writing all the code to execute this attack. So this is the paragraph you want to look at. During login, all passwords are hashed. So just have a read of that, and then we'll have a quick chat about it.
The logging for the device temperature is meant to be root 4, right?
No.
How did you get to the bit where you saw the hash? Like the block stuff?
Sorry?
How did you get to that other screen where you saw?
That's the encryption device. So the challenge here was like you need access to one device first before you can start affecting the temperature. So we'll start with that. I can see how that was confusing.
Yeah.
Sorry for that. So we're looking at the temperature gauge page, and I'll just run you through that one because that one will take too long to do just in these 2 hours. So can somebody say, tell me what are the important parts of that paragraph? Yep. Yes. That's the one. That's probably like those two things you need. Why is that important? Yeah.
It will probably give up when it finds an invalid character.
Yep.
So if you have multiple valid characters in a row, it will take longer than if you have four numbers, than if you have fewer invalid characters.
Yes. Spot on. I'll write it up. So in this case, we know that it's going to be 8 characters, and it's going to be A to Z lowercase. So that means we have A. So each letter is separately hashed. Bcrypt is slow. So Bcrypt is the right hashing algorithm for passwords, but please don't ever do it this way. So the reason why, we moved, as a sector, we moved through quite a few hashes before we arrived at Bcrypt. First we said MD5 is fine or SHA-1 is fine. What we realized is that in time, computers got so incredibly fast that we can pretty much calculate the MD5 hashes so quickly that if I get a full dump of a database, I just start looking through common passwords or so dictionary text or just pure brute force, and I'm going to hit valid passwords pretty quickly. Bcrypt is supposed to prevent this because it's a resource-intensive hashing algorithm. So Bcrypt requires a lot of CPU, and there are others that require a lot more memory. So that way you can stop these massive attacks where somebody just calculates all these hashes in one go. So what's going to happen is the first in our for loop, where we're going to go through our passwords, we have our actual password, and we get an index on the character, and then it needs to be equal to the hash character, right? Kind of makes sense. We'll hash that. I need to check the code now, because this doesn't make sense.
Hash of password I is equal to hash I.
Hash of password I equals hash of input I.
Hold on, let's just grab the code.
You have the hash password. Oh, the negative.
This is quite cool, actually. This challenge had a massive bug. So this is our check login function. So range length of the password. Yeah, so it stores the actual password in plain text, and then it grabs those and then hashes them. So bcrypt is done over this.
That's so bad.
Oh yes. But so what we try to exactly create a scenario where you can have an extremely reliable timing attack, because we have people doing timing attacks from Perth, Darwin, like anywhere around the country. So we needed to, rather than just doing a straight up sleep, which is possible as well, but just a little bit boring, we just used bcrypt on every single character, so you can do a timing attack on individual characters. So the bug here was epic, and like I was told, like I think an hour or two before we went live, and I think this was the bug. So can someone tell me what actually would happen? So sorry, I'll make that a bit bigger, because so the original code was provided password, when instead we got the length of the password stored in the database.
You get errors as soon as you think
Sorry?
password, it's not the same length.
Sorry, I'm actually making a mistake. The actual bug is in here. It grabs the length of the provided password.
Where is length 0?
So the length, like length 0 won't actually work, but the bug here is if you did just one character and you loop through A to Z, so you needed 26 characters, you would hit a valid password, because we would validate against the length of the provided password. And the first character would match, and it go, yep, you're logged in. We fixed this just before the competition started, but it's...
I don't feel so bad. Intel was doing it for years. That's horrible.
It reminds me every time that, like, even being a security person, like this is, like that's a simple bug to write, and nobody, like, that can go through full code review, and a lot of people wouldn't pick up on it. So I'm still pretty proud of writing that bug. Yeah. So yeah, you can actually now try that. So I think if you provide the letter Q, you will actually log in. This is not going incredibly quick, but what this is doing is it's just providing a password, like it's providing 8 characters, and it's just looping through, and it's keeping track of timing. So every time a request takes longer than the previous request, it will go, okay, it's probably this one. And what it has found so far, so it's starting with QU, which is correct, and it will just slowly work through all of this. So that's why this will definitely take a while for us to just write the code and then to run it. But that's how you would, in the end, would have found the password. Yes?
So is it bcrypt that's making the timing attack possible? Or?
No, it's the fact that we just use anything that's slow. So let me just show you that in a bit more detail. So what is happening is we're going through Let's just do this properly. So we're going through the range of the password, yeah? And we start with the first letter, and then the first letter that's provided. We hash those, we get 2 bcrypt hashes, and we compare those. If provided character is unequal to the actual character, which are the 2 hashes we're comparing, then we go, this is incorrect, just go away. But that means that the minute I hit an incorrect character, I will stop.
Yeah. So there's a timing difference if it's right or wrong.
Exactly. If it's right, I'll keep going, and my request will take longer. Does that make sense? Like these are like quite complex attacks, so I have no problem explaining this again.
What is your script look like for that?
My solution.
Encrypt the whole thing, would you? And then do you check char by char after you've encrypted both, hash both?
Say that again.
Would you just hash both individually? Like to not have that problem, you would just be hashing both individually and then doing the
Don't-
check after you hash? Just-
Don't ever hash individual characters. So
Just don't do that individual, I mean, just hash the whole thing once.
your, like any proper login function is just if your, so bcrypt your password plus your salt needs to be equal to your, like your value, like your password value in the database. Yeah, that's it. Login functions get really cool really quickly. And that is, you can even, if, let's do, that's horrible writing, sorry. So this is not uncommon. If username equals provided username, I'm going to continue with my if password valid function, right? And then you return true. Yeah, that's your, the cool thing here is, what if my username is valid but my password isn't and I use a slow hashing algorithm? That means that my username is just going to pass. This is going to, it's a bad example, but what's going to happen in some cases is if my username is valid, it doesn't always, this is a bad example. I'm not good at figuring stuff out on the fly.
So you're saying you can use that to figure out if you picked the correct username?
Yes.
So it doesn't matter what the password at that point.
Yes, that's what I'm saying. Yeah, you can. In some cases, you can use a similar structure to figure out valid usernames through a timing attack. Yeah.
And what solution might be, and call me crazy, don't store a password in plain text.
Basically, the advice I give developers is, if you don't ever, you don't have to write this. Like you don't have to write authentication authorization functions. Like there are platforms that are, like there are developers, like not trying to sound blunt, but they are better at this than you. And this is also stuff that's been tested, it's been reviewed, and it has been pen tested and attacked, especially if it's open source platforms. The likelihood of that happening is a bit more. So don't write this. Every time somebody writes this themselves, you should really ask the question, why are we doing this, rather than is it secure?
Can I run through your solving script?
Yes?
I actually remember now, of those 3 hours break, 1 hour was waiting for this to finish.
So this is my solution. Let's see. Do you know that feeling when you're looking at code that you wrote like 6 months ago? That's me right now. Who wrote this? Yeah, so this is probably the main area. So verification runs. Bear with me. Yeah, so what I've done is, why my script is a bit slower is because I said I want you to run a verification round, where I want you to double check if that request actually took that long. So in this case, I'm running 2 verification rounds. This is just to give a bit more confidence in my own attack. So sometimes what happens is your network just like something blips, and it takes a little bit longer. And then the second time you execute it, it happens incredibly fast. So if I use that in a timing attack, like doing 2 requests, I'm going to be a little bit more certain. So what I'm doing here is I'm just making the request, and I'm doing it again, and I grab the average of those 2 to basically say, okay, this is how I think how long the request took. Then in the next part, I actually look at what's the highest elapsed time, and is it higher than what I already have? If it's an increased amount, then I go, this is very likely taking longer. So I don't actually know how long the request is taking, so it's not like is bigger than 1.5 seconds. It's like, has this been request taken the longest out of all of the other ones in this series? And then I just start adding characters to the actual password. Or I just print out the value. So I've had it running. So I think something went wrong here. But it started off well. And I think that is correct. But yeah, that's how I solved this. Yeah, but this was hard. Was also an ambitious challenge with so many network traffic components. So the fact that it finished and you got it is quite impressive. Cool.
That gap will be more prominent the more you turn the temperature up, right? Or no?
Sorry, yeah, I confused you guys a bit. And that is because this was simply getting access to the temperature gates, because now what you can do is you can set the temperature. Set temperature. You can set using those credentials, and with that you would increase the temperature for the encryption device. Let me just run that for you. So in this case, we're setting the temperature above 100. Can everybody read this? And then what happens is if we go back to the device, we can hopefully soon. I think it's that. I'm going to have to fix this, guys. Cool. This was, the next one is the world, like the worst safe in the world, which was quite a cool idea. So this was written by my colleague Tony. And what he did is he basically copied an existing implementation of a physical safe called the SNG 6741, which had a specific lock that, do you know what leniency means when it comes down to a lock? No?
How close you can read the right answer?
Yes. Yes. Where's my marker? There we go. So I have my traditional lock, right? And I have all these, like these make the clicks. Leniency is, let's say the number I actually need to hit is 67. Next to it is 66 and 68. If I put it on 68, it will still say it's okay. That's leniency. So what Tony did is he implemented leniency into this lock, which basically means that if you have so the amount of options you have significantly reduces. So I think he had 100 positions in total, but leniency was either like 3 or 5. So it just means just reduce it, like just make steps of 3 or 5 instead of 1, which like reduces your like the amount of requests you need to fire off, like 100 per DAO. So you had 3 DAOs, reduces significantly. So it actually turns. Yes, it has an endpoint called turn. And you give it an argument which says how many you want to turn.
There's also had a bug with floating point numbers.
Yes, I just want to talk about that. So we had, like, again, epic bug. So who knows, like you all know the data type floats. What we learned quite quickly was that there are 2 additional values that are valid for float.
Negative not a number and not a number.
Not a number and infinite.
And negative variance both of those.
Yes, correct. Yes, we learned that quite quickly. And what would actually happen is, so you had three DAOs, right? And our goal was to just get you to turn them with the leniency. If you turn them by either nan or an infinite, it would just go like bang straight through. You just like all would unlock. The thing is, we found this out because somebody goes like, my whole safe is set to like unlock, to nan, and I can't get it to fix. And I go, that's strange. Just reboot your machine and you'll probably be fine. And they were. And it happened again. And so we put in the description like, don't submit infinite or nan until somebody goes like, you know that this is a valid solution for the challenge, right? So we didn't fix it because it's a great bug. And if you found it during the competition, well done. So we left it in. So yeah, don't forget if you're dealing with floats, those 2 values to check for. If they're there, should they be there? The next component, so let me just see if I can run this. Nope, that's not going to work. So this would turn it. Take a little while. And the next step I was able to do till yesterday. Who knows of request bin? So I have very sad news. They took it offline. Yeah, they had too many abuse complaints, which is very upsetting because that was like my sole CTF tool that I used pretty much everywhere. The good thing is they released a Docker instance, or like they released everything, so you can just run it yourself. So the next step here would be that once you unlock it, in the documentation there's a reference to...
Hookbit apparently is the,
Sorry?
apparently Hookbit is the new.
Oh, Hookbit is the new... Excellent.
You think it's already the
Oh, this is bad news. I'm not having a lot of luck with my environment today, but in the description it says once it's unlocked, you give it a parameter with the name of the person that is unlocking it. So this is again where the description actually gave you the answer. So someone, bear with me, I'll just find you the paragraph. Yeah, so here's kind of like Unbreakable Safe provides next generation monitoring for your safe. As soon as your safe is opened, you will receive a notification on your phone. Of course, no one could ever break, blah, yada, yada. What this probably means is that there is a process reading in the background something that you're submitting. So whenever you, in a CTF, when your data is being read by something else, like your first go-to is usually XSS. And that is, in this case, it's from here, it's a straight up XSS challenge, where you just provide the username or the person opening the, how familiar are you, by the way, with XSS vulnerabilities? Should I talk about them? Yeah? So XSS, like, the simplest way I can put it is I can execute JavaScript in your browser. That's what it is. what can I do if I can execute JavaScript in your browser? Let's say I can do this in your Gmail.
They can send you my cookie.
Yes?
Access to my account.
Yes?
You can read my emails.
I can read your emails. Yes?
Probably send an email like that.
Yes? Can send an email. I can pretty much do anything I like. I can change the page to look like a Google Gmail login page. I can send you an exploit for your browser. I can send emails. I can read emails. I can steal cookies. I can keylog.
Buy Bitcoin.
That's the hipster. I can do anything I like as long as it's valid in your browser. So from an attacker perspective, especially when you look at what does this mean for, like, what would this mean for Gmail, this would be devastating. So in this case, the goal is to just get, because there's an admin, in this case, you want to get the cookie. So you just receive the cookie. How you do that, so because we can execute JavaScript, what we do is we're just inserting a script tag, document.write, which just means like add stuff to the page, or technically replace everything on the page with this. And then we're adding an image tag with a source that is calling our URL with the value document.cookie as one of the arguments. This session hijacking, very easy to protect against. The first one is just don't have XSS. Who knows, by the way, what's the proper way to mitigate XSS vulnerabilities? Don't write JavaScript. That is a very good start.
Sanitize like it's run tomorrow?
Sorry?
Sanitize like it's run tomorrow?
Yes, but no. What's the only, like, if you can do one thing, like, let's say you had a group full of developers and you go, I'm going to ask you to do one thing to prevent XSS. What should they be doing? Encode output. Anything that is controlled by a user, you need to encode on output. So that any special character is just turned into a HTML, like that it doesn't execute. Does that make sense? Yeah. Sanitizing, yes. So security, as you know by now, it's never just one thing you do. Like just install a firewall and you'll be fine. Like no, that's not how security works. It's never how it worked. Sanitizing input can actually be incredibly useful for multiple reasons. Also, simply usability. Let's say I call to an endpoint, like I want to send an email, and in my to field I require, I need an email address. Like obviously there's not going to be a single quote in there. But purely from a security perspective, that's going to do very little because like your blacklist or your blacklist has to be complete, right? But what if I just tell you, I expect these characters? If it's not matching that, I can tell the user already, like, this is invalid input. Just go away, which is good. Somebody just might have made a typo. In your environment, you could just open a Netcat listener and just make a web call to your Netcat listener because the flag was straight in the request, in the GET request. Does that make sense? Anybody not familiar with Netcat? Excellent. What? With SOCAT?
Yeah. Well, you can get because no one's charging so it's like that.
Ah, yes. No. I'm not going to show you the code for this one, actually. My reset tokens already. So this one we can't play, but this is again built of a classic phone, and I think I'm just going to talk to them because I don't want to keep you here till like 8 and play all the challenges. I'm going to leave this environment up, so at least over the next few days you can have a look around if you want to. But when you're resetting your password, does anyone know how that flow actually works? So let's say I go to, like, let's just grab like our own virtual application, and I want to reset my password. How should that work?
You type an email address that is associated with it, and it says, good, we've sent an email. And
Yes.
then in the background, it checks if that email actually exists and sends an email to that place without resetting it. How do you reset your password?
Yes, but what is it sending?
It's sending a link with probably a token that is unique to that user.
Yes.
Times, I'm guessing, usually it's
So-
timing.
So let's talk about this token, right? Like, how would you generate this?
Randomly,
How much? How random?
I type like 20 bits of OS uranium into base 64.
Yes, that's the answer. What if I use time?
No,
But
that's predictable.
yeah, but what can I do if, let's say I have an application that uses time? How would you attack it?
Like, try and figure out when it generated the token and then generate all the same tokens for a certain time period. And generate all the tokens.
Could you try firing multiple requests at exactly the same time just to see how it's dealing with the time, like what it's actually doing on the back end?
So what will you send in these requests? Let's say you're going to fire off 2 requests to your web server. So your endpoint is like API/reset password. What would you send?
The username of A, the username of... If I've heard send username A a lot of times, it's short and simple username.
So username is A? Or yeah, username, and then in your second request,
Username A. I just hit that a lot of times.
username is A. Okay, in this request, you get 2 emails with the exact same token.
So the username B and see if it gets a similar token.
So you get username B, you don't have access to this user, and you get 1 email with your token.
Space it out a little bit more, see how long you can push that time between the 2 requests.
So you don't know the token for this one, right? You only get the token for this one.
A, just fire a second one, but give it a known delay so you know that they're not arriving at the same time.
Okay, so
See how accurate their time is.
so you'd wait, and then you do username
Yep.
equals A. Your token changes. You have a different token.
Yep.
It's like, let's say it's based on time with a second.
Can we make another account? Can we make a user B or a user A?
I don't think you need to. Let's change it up a little bit, right? Like, let's make it a bit clearer. But this is you. And let's go back to the scenario where we were. You and admin. So you request at the exact same time a reset password for you and the admin account.
Using the same random. Yeah, but the time, it's using time to randomize them, but it's the same number that they're both randomized with. You know what you put into yours.
Yes?
If you can find out what's actually changing.
What if you just leave it? You have a reset token that is valid for admin, right?
It doesn't do anything to it to add the username at all. It's just the number, is it?
Just
Is it
you just get the token back, and your token, and they're the same. So I just go to my reset password page, and doesn't matter. So okay, how this would work? Let's say you do this in Gmail. I go, send me a reset password to this email, to my Gmail. You get in your Gmail, you get your link with your reset password link. I grab that link, there's probably in the URL, there's your username and your reset token. I just changed the username to admin because I have the exact same reset token. That's how this one would work. It's just slightly different because the token was sent to like a phone. So it gave you like a command line phone application that would send you a token that you would use to reset. Not as uncommon as you might think. Anytime you're testing anything with like tokens that are coming back, what's happening if you request at the exact same time twice?
So with that challenge, was there an indication that that's what it was, like that it was a timing issue, or was that something that you were expected to just try?
I don't think so. I think that was kind of like, let's have a look. Where was it again? Was it Mail Monitor? Yeah, no, it was. I think it was expected that you kind of figured that out. That there's a reset password, and a reset token is required to send to your phone. Yeah. Yeah. If they have re-released Cysca in a box, in this case, the environment, you won't be able to have the phone because I just didn't have time to set that up. But in Cysca in a box, that should be there. So you should be able to play this one. You can't give a presentation working in information security without having two people type on the same keyboard. It's so fast. This one was probably like the one that you just went like, what is this?
This is the worst challenge.
Yeah. So if you didn't notice already, I'm originally from the Netherlands, so I figured I'd throw in one Dutch word to just take the opportunity to teach you something else that isn't information security. Lampje is actually a reference to Donald Duck's, like, what do you call the professor? No? No? Donald Duck fans? I grew up with Donald Duck. Anyway, do you know the little lamp? Anyway, it's okay. Oh, okay. Yeah.
Is that who you're talking about?
Yep. Anyway, doesn't really matter. This one was a bit more of a classic CTF challenge where what happened is the login credentials you found on that picture before, you need it now. So you could log into just using the credentials here. And I'm just going to see if I can get those credentials up there.
How stupid are you supposed to do at 3 a.m. in the morning?
I do.
Like, you just saw a GIF on the screen and it's like, why is it flashing black, white, and gray?
So it takes a while to download because it's actually quite a big GIF. But
So we had a week CTF and had a challenge where there was a GIF of just GIF flashing black and white. If you used GIF to split up frame by frame,
yep.
you could analyze to see the long and the short and all stuff of results.
It's exactly the same. Yeah. So I'll just show you. Oh yeah, there we go. So.
It took a lot of tries.
So once the GIF is actually fully downloaded, like you obviously you have to download it. I keep doing this, but I need to be here. What you do is So luckily, Kali comes with all the right tools. And what you do is you grab the file, and you basically just split it into all the separate frames. So every frame you take apart, and then you can basically, like it gives you the time frame, like how long it takes. I think it's 0.6 seconds that it flashes. So, and there's a black frame in there as well to indicate the stop of each character. And then you just translate it like straight into Morse code. And you're done. Well done. 18 hours. I was very impressed. I was very tired by then.
That was a trip to Macca's to realize what the fuck was going on.
Yeah.
I remember your complaints. Is it really just Morse code?
How was the test? When in doubt, it matters.
It's flashing things Morse code. Yeah.
Yeah, no, like, that's kind of the last one I want to talk about. I hope this was useful. I hope it was not just me talking here. Like, I love CTFs. I think you have a great community here of CTF players going on. Please keep that going, because I think it's incredibly important, because it teaches you how to think about these problems, not just go into like whatever job you're going to do and just click on buttons and type lines of code. It teaches you how to think like somebody who needs to solve problems. So it's been always a good lesson for me. So yeah, thanks. I'll stick around for a little bit. So if you have questions about any of the challenges, or if you just want to have a chat, feel free to come over. Yeah, but thank you all.